Hello, young chemists. Have you ever noticed how your bathroom salt shaker clumps together when it's humid, or how salt crystals can vanish into thin air? This curious behavior happens with certain substances, and today we'll explore efflorescence and deliquescence, two fascinating chemical phenomena. Efflorescent substances are salts that, when exposed to air, lose water and turn into a powdery substance. But on the flip side, deliquescent substances are salts that actually absorb water from the air, forming a liquid solution. Let's break down both concepts and understand the chemistry behind them. Let's start with efflorescent substances. These are hydrated salts, which means they contain water molecules within their crystal structure. Think of them as little sponges holding water. But when exposed to the air, they release that moisture, causing the substance to dry out and form a powder. A great example is washing soda, which is chemically known as Na2CO3.10H2O. When exposed to air, it loses its water and turns into a white powder. The equation looks like this: Na2CO3.10H2O gives Na2CO3 plus 10H2O. This process is driven by a difference in vapor pressure. The vapor pressure of the salt is higher than the surrounding air, so water is lost. Imagine how your skin feels dry after a swim. That's efflorescence, but on a chemical scale. Now, let's talk about deliquescent substances. Unlike efflorescent substances, these salts are moisture magnets. They absorb water from the surrounding air and dissolve into it, forming a liquid solution. Calcium chloride is a great example. When you leave it out in the open, it absorbs water and becomes liquid. The reaction can be written as CaCl2 plus H2O gives CaCl2.H2O. This happens because the vapor pressure of these salts is very low compared to the moisture in the air, so they readily absorb water. This property is why we use calcium chloride in dehumidifiers and do melt ice on roads during winter. So, what's the difference between these two processes? Well, efflorescence happens when a salt loses moisture because its vapor pressure is higher than the surrounding air. Meanwhile, deliquescence occurs when a substance's vapor pressure is so low that it attracts and dissolves moisture from the air. It's all about how these salts interact with their environment. Efflorescent substances leave behind a solid, dry residue, while deliquescent substances turn into liquid. Take a moment to think about how salt might form a dry powder on a hot summer day, while certain salts might turn to a puddle in a humid room. These fascinating properties of efflorescence and deliquescence aren't just chemistry in the classroom, they have real-world uses. Efflorescent substances like silica gel are used as desiccants, which are materials that absorb moisture and keep things dry. You may have found these little packets in shoeboxes or electronics. On the other hand, deliquescent substances are used in drying applications. Calcium chloride, for instance, is used in road maintenance to clear snow and ice because it absorbs moisture and melts the ice. So, next time you see a dehumidifier or a moisture-absorbing packet, remember, chemistry is at work. To recap, efflorescent substances lose moisture and form powder when exposed to air, while deliquescent substances absorb moisture and dissolve into a liquid. These processes are driven by differences in vapor pressure, and they have many practical uses, from dehumidifiers to road salt. So, remember, chemistry is not just confined to the lab, it's the invisible force that helps us in our everyday lives. I hope this session helped you see how chemistry works behind the scenes. Catch you in the next class, where we'll dive into more amazing chemical reactions and real-life connections.